knowledge representation about the word in a form that computer can use that knowledge, that information to solve complex problems, complex tasks, such as diagnosing a medical condition, or having a dialogue in natural language, or you could say how the the things can be explored in space, right? How automation can help industry. Many such areas are there where how knowledge can be represented using machines, right, to solve a particular problem, human knowledge basically. So it refers the technical problem of encoding of human knowledge and reasoning. It is all about human intelligence and behavior that we want to encode into artificial things. That is all about AI and knowledge representation. So we'll give more focus on this, how human intelligence, how human behavior can be encoded, can be added into artificial things, artificial entities. It could be anything around us. We have many artificial or things around us which by themselves do not think, by themselves do not move at all. So can we add intelligence? Can we add computer program into it and make that things movable, make that things to perform certain tasks? Yes, we can do it, right? But how? That we will explore throughout the session today. So that is how many topics today I'll be covering over the time. Students, are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Are you understanding it?
Yes,
Yes,
sir.
sir. Yes.
So let us move ahead and let us try to understand first what is AI. So what is AI, right? So there could be many possible ways. You can refer many books, many literatures, right? Many places where AI is defined precisely, right? So we will discuss, one of its way of how to understand AI. So AI is basically concerned with design of intelligence in an artificial device. As mentioned before, it was, the AI term was coined by McCarthy in 1956. But if you read that first line again, right? Artificial intelligence is concerned with design of intelligence in an artificial device. So there are two ideas in the definition. One is intelligence, and the other one is artificial device. Artificial device you could understand, right? But what does mean by intelligence? If you could understand intelligence, you will definitely understand artificial intelligence and all the techniques associated in. So what is intelligence? May I ask you? Can anybody of you? We'll try to make it as interactive as possible. So yes, any one of you? What is intelligence? So I'll explain something, and then if you want to speak,
Who is
then you
perform tasks itself?
okay. If anything perform task itself, that does mean intelligence, right? That you want to
Yes,
say?
sir.
Okay, good initiative, Sagar, right? So basically,
Yes, sir.
I will ask some questions and then you will try to understand it, right? So what is intelligence? Is it that which characterize humans, that this human or this person is intelligent because he has completed that much qualification, right? Because he has a lot of success in his life, or maybe he's a successful businessman, he's a successful entrepreneur, or maybe he's a successful person in the industry. So what basically decides that human is intelligent? So what is the characteristic? Is it that the characteristic of human, the way you describe what is intelligence? Or is it like some absolute standard of judgment? Okay, because he took that decision, because he handled that situation, because he said, he took that risk, that's how he's intelligence. Is it like that? If you think that then there are two possibilities. One, a system with intelligence is expected to behave, right? Mention, please note down. A system with intelligence, an artificial, entity is with intelligence, basically, I'm saying, is expected to behave as intelligently as human. The way human learn, the way human think, the way human make decision and take action. Is it like that? That does mean intelligence, right? So how human brain or basically human learns over the year, that is a mystery, and that is what all scientists are exploring and studying since last century. or so. Or there could be a possibility that a system with intelligence is expected to behave in the best possible manner. Whatever the situation come around it, it may or may not have some knowledge what to do next, but it still should perform in the best possible manner. It should handle the situation. That knowledge is not available. But how to react to certain situations, certain events, how to deal with such circumstances, that does mean my intelligence. So human basically certain things, these situations in their life, right? They build their knowledge over the years through education system, through society, through learning, interacting, through experience. But can machine do that? Can machine think? Can machine learn? Can machine pursue? Can machine take actions, reasonable actions, so that whatever they will do, they will perform, that will be some perfect or accurate. So how basically it can be done? So can we add human intelligence into machine? That is the topic, that is the discussion, right? So we'll more focus on this. Now if you look at the definitions given here, there could be many possible ways how we can define AI. So it is a branch of computer science that pursues creating the computers or machines as intelligent as human beings. So what is AI? AI means creating machines like human beings. Or we can also define it as like the science and engineering of making intelligent machines, especially intelligent computer programs. Because if you develop an intelligent programs, obviously you can make things work, right? You can make things work, you can make computer work, you can make your desk work, you can make your anything, any entity work, right? Or it is related to some similar task of using computers to understand human intelligence. So AI does not have to confine itself to methods that are biologically observable, but intelligence, which is real importance here. So you can read the definition given here is the study of how to make computers do things which at the moment people do better than anybody else. So according to John McCarthy, he has defined, his definition is referred everywhere. So he has defined the AI as the science and engineering of making intelligent machines, especially intelligent computer programs. So it is a way of making computer controlled robot or a software, right? Three important things mentioned here. Computers, right? We are using it for everything. Computer controlled robot, a specialized machines, right? Intelligent machines, and a software, a computer program, basically think intelligently. In this similar manner, the human thinks. So it is all about human thinking. Hmm? So AI is accomplished by studying how human brain thinks, how humans learns, decide, and work while trying to solve a problem. And then using the outcomes of that learning, that study, as the basis of developing intelligent software and system. So how human learn, decide, work, take action, react to certain situations, that is that is the area of interest. That is the study which is basically an input for intelligent machines, intelligent software, intelligent systems, right? So that is what. So later we will discuss some more definitions and and some approaches how basically AI is evolved over the time, taking into consideration this human intelligence. Now let us move ahead. There are certain key terminologies used in AI. I'll be using it, in the on the rest of the slide, in the rest of the discussions as well. So here I'll introduce you with this terminologies. Intelligence. When I say intelligence, it basically relates to tasks involving higher mental processes. So can you give some examples here? You describe what is intelligence. Intelligence means it involves some higher mental processes. It's about some um, we cannot measure it first of all, but it could be like how human thinks, how human take decisions and take actions. So can you give some examples of it? Intelligence. How? Yes. Yes.
Understanding something, sir.
Understanding something. Good. Yes. Anybody else?
For example, Alexa.
Alexa, how that a computer program works, how it takes input and then give you some desirable output, or maybe a smart search, right? Then there are many examples around us. So if you want to understand the intelligence, how human brain basically think and then work, so you can give an example of creativity or problem solving or pattern recognition, classification, learning, induction, deduction, building analogies, optimization, language processing, knowledge, right? And many such other things which can be termed as an intelligence, human intelligence, right? So, intelligence is basically the computational part of the ability, human ability basically, to achieve certain goals, right? So humans use their intelligence which they have developed over the time. Like now, by this time you are 20, 22 years old, so you have developed some intelligence over the time, right? And you use that intelligence to achieve certain goals in your life as a human. So can machine do that? Can we develop machine over the period so that that machine can learn through interaction with, you know, with other machines in the environment, humans, or maybe it will learn through its actions, reactions, and the experiences it takes over the time? And can that program, that computer program, that artificial machine can become intelligent over the time, the way you become it today? So that is the intelligent behavior. So what is intelligent behavior? Basically how one perceive the environment, how we understand the environment around us, the circumstances around us, situations, and then how we act in the normal situation, how we act in the complex situation, how we act in the complex environment, right? And then learning and understanding from experience, right? So you have an intelligent behavior, what to speak, where to speak, right, when to speak, right? You are intelligent one because you have that understanding. You learn over the time how to behave, right, and how to speak, when to speak. So that is an intelligence as far as speaking is concerned, as far as communication is concerned. There could be many different intelligences there. So we'll be discussing different types of intelligence in the later part of this session, right? So learning and understanding from experience, then the reasoning and understanding from experience, then discovery and understanding from experience, then logic and understanding from experience. And what logic you have applied, what method you have applied, is that method itself have a good performance? It means you take time to solve a particular problem. How much time you took? The other solutions exist, but they took less time and you took more time. So it means your solution is not the best solution, or maybe the method, the logic you are applying is not the best one. So how to come with some, the best possible outcome, the best possible approach to solve a given problem, right? So reasoning to solve problem, and then discover hidden knowledge, apply knowledge successfully in new situation, think abstractly, using some analogies, communicating with others, and much more. So intelligent behavior can be many such things, right? Then what are the science based goals? What, there are scientists, there are engineers, there are many other disciplines working on the AI. So what could be the possible science based goals of AI? So basically, science-based goals of AI are to develop concepts or mechanisms or some understanding of the biological intelligent behavior. Biological intelligent behavior means it is a study. The emphasis is given on understanding how human brain works. Look, the science-based goals are how human brain works, or I would say how human works, how human thinks, how human perceive, how human learn. That is the study, and that is what the focus of science when it comes to the AI and its disciplines. So what are the engineering based goals of AI? So basically engineering based goals of AI are to develop some concepts, some theories, some intelligent machines, right? Or to build some smart machines or intelligence entities. So emphasis is given on building, emphasis is given on development, emphasis is given on something on creativity. So engineers basically focus on developing smart machines, intelligent machines, like driverless cars, like smart cars, right? Like smartphones, right? Like reusable rockets, right? So there are many such examples we have, right? So engineering focus on developing. Science is basically focus on studying how it works. And then if you can understand how it works, then you can add that intelligence into artificial thing and make that artificial thing think and work like human, think and behave like human. So it could be artificial human, or artificial some machine which can perform all human tasks, right? So that are the engineering being goes. I hope you understand the difference between science and engineering as far as AI is concerned. Did you?
Yes, sir.
Okay, thanks. Then AI techniques. So what could be possible techniques, right? This is just an some introductory topics. I just want to put highlight onto it because these terms will come again and again, and topics like this are really heavy to digest, AI and knowledge representation. So I just making it as simple as possible for you. So what is AI technique? What does it mean by? It means how we represent, manipulate, and reason with knowledge. We have a knowledge, right? You have a knowledge, I have a knowledge, many among us have a knowledge. So basically how we represent it, and then how we use it, basically how we manipulate, improve it over the time and use it at the appropriate situation, right? So to solve problems or to deal with certain situation, that does mean by AI technique. So whatever the the techniques like search algorithms or maybe some representations in AI, we will see later on, semantic network, logical representation, all basically use these techniques are used to solve a problem anyway. But how we could solve a problem through some knowledge representation with some reasoning, with some logic, right? And how we can encode that logic, that computer program into machine, so that machine will start thinking, start behaving like you. So that is AI technique basically. So knowledge is a collection of facts, and these to manipulate these facts, basically knowledge, by any computer program, a suitable representation is required. And that's why knowledge representation we will be discussing in detail in the second part of the session to solve problems in real life. Then learning means computer program. See, our focus is on an intelligent program, computer program. So learning with respect to computer program means program should learn from what facts or behavior human basically represent. Or learning denote changes in the system that are adaptive, or it enables the system to the same task more efficiently next time. Like in the first trial, you achieve a certain goal, maybe 50%. Then you understand why you lack the success, why you got only 50% success, and then you trying to understand the other aspect of performing the same task, and then you improved in the next time 70%, and you go up and see now you are up to 90%. So this is how basically human improve over the time. They learn from their mistakes. So can machine learn from their mistakes? That is the goal. So learning. Then applications. There are limitless applications of AI. I would mention some of here: problem solving, search, control strategies, speech recognition, natural language understanding, natural language processing, computer vision, expert system, medical diagnosis, pharmaceuticals, many. In the later part of the slide, I will also list out some more applications of AI, right? Now what agent? Agent is the more commonly used term in the AI. In AI system, basically the artificial system with all its necessary control parts and computer program is composed of an agent. Basically, agent is nothing but a simple computer program, and it is associated with its environment. So to that computer program, certain environment situation is given, and the computer program is developed in such a way that it should understand the environment and then act accordingly. Right? If I build a robot to, for some household services, like I am expecting that robot should go and get me a drink, a glass of water, right? So that robot should work like this, right? So basically, agent act in their environment the way we have designed it, right? The environment may contain some other agents as well, right? While that agent will start moving towards where the water pot is kept, right? And some obstacle, maybe table, chair, may come in between when that robot will start to move from one place to the other. So it means there are other agents exist in the environment, and that robot should avoid the obstacles coming in between to reach to the water pot. So how basically this is being understood by that robot or by the agent, some computer programs which we have added into that robot or that intelligent machines. So robot is anything that can perceive its environment through sensors, right? Obviously we will build some robot, it will definitely have some robot sensors, right? And through that sensor it should perceive and learn, right? There are obstacles, there is a chamber, I should take the other move and the other way to reach to the water pot, right? So sensors, and then acts upon that environment through effectors. So there are effectors as well. Now what does mean by rationality and rational agent? So rationality, because these terms are coming up in the later part of the discussion, so that's why I have introduced it. So what does mean by rational agent? Rationality is nothing but status of being reasonable, sensible, having good sense of judgment. Like you perform certain action, why you perform that action, right? You take a glass of water, right, and drink it. Why you have performed that action? Because you were feeling thirsty. That's why you drink a glass of water, right? So there is a reason, right, why you drink a glass of water. So it means whatever the action being performed by the agent or by the robot or an intelligent machine, that action must be reasonable, having good sense of judgment. Why did it perform, right? And it depends on, again, its learning, perceptions and all. So we will explore more on the agents and rational agents in the later part, but this is just an introduction. So ideal rational agent is one which is capable of doing some expected actions to maximize its performance, to improve its performance basically, and it depends on its built-in knowledge, right? I should have a knowledge that whenever I feel thirsty, I should drink water, not any fuel, not any other type of liquid. So that is a built-in knowledge we have, humans have. So can machine understand how to react to certain situation like this? So it depends on its perceptions. Over the time it gains and improve its knowledge base, and the process sequence also, what in what sequence it performs certain actions and reach its desired goal, right? So that is basically a logic and study behind it. So I hope you are understanding with me, everyone.
Yes, sir.
Good. Now we know when it comes to machine learning or deep learning, these are basically subsets of AI, as you can see in the picture as well. So machine learning is a branch of AI and computer science, which basically focuses on the use of data and algorithms to imitate the way human learns and gradually improving its accuracy. So machine learning is a science of getting computers to act without being explicitly programmed. Look at the words, machine learning. So over the time, machine will learn whatever we have in initial setup. We have have certain built-in knowledge added into the machine. By using that knowledge base, built-in knowledge, machine will start learning and then will start taking necessary actions, and those actions now there are ways how we can assess those actions, its performance, the time complexity, right, and some other measures would be there, right? But basically machine learning is a science of getting computers to act, machines to act, artificial things to act without being explicitly programmed. So in the past decade, machine learning has given us self-driving cars, practical speech recognition, effective web search, and many other applications around us. Even we do not realize there are many machine learning based technologies we are using today. I'll give you some examples, right, in a while. So machine learning is so pervasive today that you probably use dozens of, such applications, but you are not aware of it. So many researchers also think it is the best way to make human progress towards human level AI. While deep learning is a machine learning testing, but because you can see in the picture, it is further subset of the machine learning, right? So deep learning is a machine learning technique that teaches computers to do what comes naturally to humans, right? So can I ask you a question? How you learn? Very simple question. Can you answer it? How you learn? As a human, how you learn? Yes.
By observing.
By observing. Good. Any other answer?
Reading.
By reading. Yes, it's also correct. Yes. Any other
Practice.
answer?
Reading,
Practice. Yes.
writing,
Yes.
listening, speaking.
Yes. Yes.
And
Basically, yes, you perform this task, right? You read, you listen, right? And then you practice, you take experiences, right? And basically you take actions also. And that is how you learn through, it's results and all. Basically, you learn by example, right? You learn by example. You perform certain tasks, and that task involves like listening, writing, speaking, performing certain actions and all. So basically you learn, human learns by examples. So can machine learn by example? That is the topic. Can machine learn by examples, right? So that is deep learning basically. So it is a key technology behind, we have Tesla is developing driverless cars. So it is a technology behind driverless cars, smart cars, and enabling them to recognize some stop sign, coming when the car will be driving on the road. So whenever it will come across some abstract or some stop sign, some traffic signal, it should stop. It should distinguish between the pedestrian and the street lamp, right? It should distinguish any object coming in between, right? So it should learn by example over the time, because we cannot add all the knowledge into the machine at a time, right? It is impossible. It is impractical at all. So machine should learn over the time, learn by example, learn by experiences, learn by listening, learn by right, then performing certain tasks, and then it should act in a best possible manner. That does mean by deep learning. So it is a key. You have some voice control devices around us like phones, tablets, TVs, and then hand speaker. There the deep learning is used, right? And deep learning getting lots of attentions little lately, but for a good reason. That's why we have a lot of utilities around us, and it helps us to achieve many possible and realistic results that were not possible before. So in deep learning, basically computer model learns to perform classification tasks directly from images, text, sounds, or other objects, and it models can achieve state of the art accuracy, sometimes exceeding the human level performance as well, because these are the machine, even though those are man-made, but because they are learning by themselves, so in some cases they are really superior than human thinking and human intelligence. So models are trained by using some large set of labeled data, neural network architecture, and then contain many layers. So if we discuss this is really beyond the scope of today's session, but these are really important technologies around us. AI, as mentioned before, is an umbrella term. It is a multidisciplinary term, as you can see. Then machine learning, and then deep. Now let's see some examples of machine learning and deep learning. Machine learning, what it is? Some examples. Can you give? Yes. Any example around you? Machine learning. Isn't image recognition is an example of machine learning?
Yes, sir.
For example, label an X-ray that it is cancerous. It should detect that the patient has some disease because the X-ray look like this, and this it is observed because this pattern is something different, right? And
Yes, lock.
it should, yes, then, or you use the social media and there you tag the person, or the social media itself, the social media platform itself help you to know, is this the person, right? So tagging, a photograph face on the social media, so assigning a name to it. So Facebook have introduced that features long back, and wherever your photographs are uploaded on the Facebook is recommending you, is that you in that picture, right? Have you noticed that?
Yes, sir.
Yes, so that is a deep learning. That is a machine learning basically, because they have developed a program in such a way that it helps, you know, people like us, users of that system, to understand, what is this thing. Speech recognition is also an example. Voice search, voice dialing, appliance control. You can give voice instructions and control, things, devices around you, right? So speech recognition is a machine learning example. Then medical diagnosis, statistical and predictive analytics are among other examples. What about deep learning? Do you know any such examples around you? Yes, deep learning.
Fingerprint lock.
Finger biometric, basically you want to make, right? Biometric
Yeah.
identification, right? So yes, it is. Then don't you know Alexa, Siri, and Cortana?
Sir, bot chat.
Yes, bots, right? Good.
Yes, sir.
Chat boards, service boards. Facial recognition is also part of biometric recognition. Fingerprints, right? Retina. And then it is also used in medicine, pharmaceuticals, medical diagnosis, translations. The translation of one language to another, it is really beneficial for travelers, right? Around those who travel around the world or to the different regional places. Then virtual assistants, you know very well, Alexa, Siri, and Cortana, isn't it? Yes,
Yes, sir.
Alexa, Siri, and topics. Now let's move on to other. I hope you're enjoying and understanding it as well.
Yes, sir.
Students, may I get to know your feedback?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So wherever you have a question or where you would like to add something, please let me know.
Okay, sir.
Now let's move on to the very important aspect of. Student, please mute yourself. Student, please keep your microphones on mute.
Sure, sir.
Okay. Now let us look at this. What is AI? This is Russell and Norvig. They are the the famous author of the book Artificial Intelligence. So they have referred the definitions and the way the AI technology being understood and implemented by other authors, other researchers, right? And they took some definitions out of it. So they have referred different eight textbooks and understood how they have defined and implemented AI as per their understanding. And Russell and Norvig have categorized these definition into 4 parts. Basically, 2 of them are based on the human intelligence, and 2 of them are based on the rationality. Even 2 of them are based on horizontally, 2 of them are based on the the thought process and reasoning, and 2 of them are based on the human behavior. Basically, the behavior of human or machines. So they have categorized all these definitions into 4 approaches: thinking humanly, thinking rationally, acting humanly, and acting rationally. So let us look at this definition more closely. thinking humanly. Hoglan in 1985 defined AI as the exciting new effort to make computers think, machines with minds in the full and literal sense. While Bellman in 1978 defined AI as the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and learning. When it comes to thinking rationally, thinking and rationally means with some reason, with some sensible judgment, with some logic, right? So in 1978, Carnegie and McDonald define AI as the study of mental faculties through the use of computational models, while Winston in 92 defined it as the study of the computations that make it possible to perceive, reason, and act. Right? So that was all about thinking rationally, thinking with some logic, right? Reason. Now let's move on to the action, acting humanly. So Kurzweil in 1990 defined AI as the art of creating machines that perform, look, action, that perform functions that require intelligence when performed by the people. So how people perform actions, can machine perform that, right? Continuing in that, in 1991, Rich and Knight defined it as the study of how to make computers do things, again an action, at which at the moment people are better. So like the people are intelligent and smart, can machine become smart? Can machine become intelligent? Right? So that was the focus. And then in the fourth approach, acting rationally, there the Shakal 1990 defined AI as a field of study that seeks to explain and emulate intelligent behavior in terms of computational processes. So look at this intelligent behavior mention with some reason, right? And then in 1993, Luger and Stubberfield have mentioned it as the branch of computer science that is concerned with the automation of intelligent behavior. Now, let us try to understand all this definition little closely. These definitions vary along two dimensions. Roughly, the ones on the top concern with thought process and reasoning, whereas the ones on the bottom address behavior. So top two are basically thought process and reasoning, and bottom two are behavior. The definitions on the left measure the success in terms of fidelity to human performance, whereas the ones on the right measure against an ideal concept of intelligence, which we call rationality, right? A system is rational if it does the right thing given what it knows. So historically, all these four approaches to AI have been followed. And even I would say today it is being followed by all the researchers and innovators, those who develop AI-based technologies. As one might expect that there might be some difference between these approaches, but these approaches basically centered around humans and approaches around rationality, right? It means human intelligence, human behavior, and logic, right? Reasons. So that is the focus of all these definitions. If we say human-centered approach, it must be an empirical science involving hypotheses and some experimental confirmation. When we say rationality, it means it involves a combination of mathematics and engineering, because you are reasoning something, you have applying certain logic, you are applying certain mathematical models, engineering behind it, and proving it scientifically. Yes, this is correct action. This is the correct reason of it, right? So that does mean by rationality. Now let's move on to the other slide and see this definition little closely. Thinking humanly, that does mean the cognitive modeling approach of the AI. If we are going to say that a given computer program thinks like a human, or a given machine, right, artificial or intelligent machine thinks like a human, we must have some way of determining how human thinks. If we could understand how human thinks, then we can add that intelligence into the machine and make machine thinks like human. So we need to get inside the actual working of human minds, right? That does mean by thinking humanly. That is the cognitive approach. So there are ways to do this. So how you can go and get to know how human mind works? Can you tell me? How you would know, or how you would study, how you would understand how human mind works? Yes. Maybe through introspection, like you will try to catch your own thoughts as they go by through some psychological experiment. You will constantly observe what you are thinking, what you are doing, and just making certain observation, writing it down. And this is how you can study the human brains.
Yes, sir.
Right. Or maybe you do certain experimentation, that what if certain situation occur, or what had happened, and then how you or some other human have took the action, took the decisions, and overcome or solve the problem, right? So this could be
Yes, sir.
possible ways how you can study how human brain works. So there, that interdisciplinary field where this human mind and how it works, that study perform in the cognitive science. This is an interdisciplinary field where this task or this kind of studies perform, and which brings together computer models from AI and experimental techniques from psychology as well, because you have to understand the human psychology, how human think and work. And combination of this computer model and human psychology, and it will help to build some theories, some testable theories, some concepts, some models of human working mind. And that is basically the logic, the rationality, this four definition we have mentioned. If we could understand how human works, and then we can make machine think like that, work like that. The other aspect is thinking rationally, the laws of thought approach. In this, the whole emphasis was on the correct inferences. Correct. If something is happened, then what you should infer from it, right? What logic you should apply or infer from it, why did it happen? Then what next? What could be the next action? What could be the next possibility, right? What will happen next, like this. So make correct inferences is sometimes part of being a rational agent. Because one way to act rationally is to reason logically to the conclusion that given action will achieve one's goal. If I would perform certain action, then when I will be getting that outcome. I want to reach to other place, then I would from what particular route I should travel so that I will reach there in a minimum time, right? It will cost me less time and money both if I'm using a public transport, right? So this way, basically, there must be some rational thinking, and then the action will be taken accordingly to achieve certain goals, right? And make reaching to some logical conclusion. On the other hand, correct inferences, that does not mean all the rationality involved in it, because there are some situation may arise when you do not have a prior knowledge as well, and there are no probable things that that action is correct, or if you perform certain action that you will definitely get this desirable outcome. No, certain situation definitely will occur where you have to apply the understanding, intelligence, basically what intelligence we are saying again and again, and you have to perform the action, whatever the outcomes will come, because you are facing the situation, you don't know what to do next, you don't have some the built-in knowledge, the earlier experiences of that situation, but still you have to perform it, right? So it may happen sometime. It means sometimes you cannot apply that laws of thought, the knowledge, you have to just perform the action, right? That does mean by thinking rationally. Can machine do like this? Then acting humanly, it basically a Turing test approach. Alan Turing is also known as the father of computer science, right? And is one of the most prestigious award given after him is the Turing Award in the in the technology industry, in IT and computer science. So Alan Turing proposed the Turing test by propose himself. It is basically an imitation game, and it was designed to provide a satisfactory operational definition of intelligence. So rather than proposing a long and perhaps controversial list of qualifications required for intelligence, intelligence means this, it should match this parameters, this list of certain criteria, and only then something become intelligent. So he suggested a test based on some imitation game, right? and that is called as Turing test. And so in the later part of the session, we will be discussing the Turing test in detail also. I'll give you an example of it also. Then this Turing test, to work on, it requires basically some other technologies, right? The other capabilities in it, so that if you want to try whether the human is as intelligent, the machine is as intelligent as human or not, then you would need these technologies to be there in the Turing test. Natural language processing to enable it to communicate successfully in English or maybe in some other language. Knowledge representation, if some queries, some questions, some input is given to the machine, then how it should understand and create some knowledge, right, uh, in it. Then automated reasoning, it also require to use the stored information in the knowledge base to answer questions and draw some new logic, new conclusion, new inferences out of it. Machine learning, it also require to adapt to new circumstances, to learn, to detect and learn and explore more, right? Infer more out of it. Then computer vision, basically cameras, sensors to perceive object, right? And robotics also to manipulate objects and move objects, like as I mentioned, effectors. You need some body parts or some parts so that that machine can move, can take certain action, can pick the object, can drop the object, right? Something like this. So these 6 disciplines, I would repeat it, this 6 discipline: natural language processing, NLP is written there, knowledge representation, automated reasoning, machine learning, computer vision, and robotics, compose most of the artificial intelligence, right? This is what the important components of the AI. And the Alan Turing, he proposed the Turing test, and that test deserves a credit, designing the test that remains relevant and challenging enough since last so many decades. It is still one of the most challenging tests in the history, Turing test. So we'll be discussing that test in the later part of the discussion. Finally, acting rationally. So rational agent approach means, we have mentioned before, agent is just something that perceives and acts, but computer agents are expected to have other attributes that distinguish themselves just mere computer program, such as operating under autonomous control. What if I just make that intelligent machine to go into some unknown environment, how it will behave there, how it will act there, how it will make some movements there, right? Like the example I have mentioned, I want my home robot to go and get me a glass of water. So how it would go and work and get me a glass of water, right? So that does mean that. Then perceiving their environment, persisting over prolonged time period, adapting the change, being capable of thinking another goals. That does mean by acting rationally, right? It should learn and understand and reason with its own action and come with some best possible outcomes, right? The best expected outcome as well. That does mean by the acting rationally, the rational agent approach. I hope you understand these definitions as well. Did you?
Yes, sir.
Right? Have all of you?
Yes, sir.
Yes, sir.
These are really important definitions when it comes to the AI. As I've mentioned, there are many ways to understand what is this technology. But I have emphasized more on the 4 approaches given by the Russell and Norvig, how they have defined it very smartly and systematically. What would be the AI with respect to human intelligence and machine intelligence, right? Fine, let's move on to the next. What are the real life applications, role of AI in daily lives? So this picture, this list is enough for you to understand what role AI is playing in our day-to-day life. AI is everywhere. As you know, machine learning and deep learning are already part of AI. So we could say that AI is everywhere. So it is there in game playing, search engines, theorem proving, driverless cars, aircraft, autoloaders, medical diagnoses, expert systems, information retrievals, music compositions, space explorations, finance, then military planning, retailing, manufacturing, inventory control, genetic research, microsurgery, environmental monitoring, dispensing legal advice, cryptanalysis, surveillance, traffic control, and many other such applications around us, right? So you could not just restrict the capabilities of AI. AI is everywhere in one or the other form. We just have to understand it, how that particular technology is letting us making use of the technology itself and making our life more comfortable than earlier. Then history of AI. I'll give a quick overview of history of AI here. I have summarized many points here over the years, so it will help you to understand, to quickly go through the historical part, how AI has been evolved over the 20th and 21st century. We are moving toward the 21st century, right? So in 1923, you can see Carl Capek play named Rossum Universal Robots opens in London. First use of robot word of that was made in that play act in 1923. Then in 43, foundations of neural network laid. In 1945, Isaac Asimov, a Columbia University alumni, coined the term robotics. Then in 50, Alan Turing introduced the Turing Test for evaluation of intelligence and published Computing Machinery and Intelligence. That time, everybody thought Alan Turing is has some problem with him. He came up with some Turing test, and he has also posed an important question: can machine think? So everybody was fooling Alan that machine could not think. Machine can never think and all. But today we know what is happening around us, right? So Alan Turing introduced that Turing test and posed an important questions in the history, that can machine think like humans, right? Then Cloud Shannon published detailed analysis of chess playing as a search algorithm, basically a search algorithm. Then in 56, John McCarthy coined this term as artificial intelligence, and he's also known as the father of AI, and demonstration of the first running AI program at Carnegie Mellon University. In 58, John McCarthy invents Lisp processing programming language for AI, most popularly known and used programming language for AI. 64, Danny Babro dissertation at MIT showed that computers can understand NLP well enough to solve algebra word problems correctly. In 65, Weizenbaum at MIT built ELIZA, an interactive problem that carries on a dialogue in English. What we see today, Siri, Alexa, or maybe Cortana, are the outcomes of this technology, which were thought before, decades back. What we see today is not just an overnight development, overnight innovations. It has come through centuries. So that is what we are, basically discussing here. In 69, scientists at Stanford Research Institute developed Shaki, a robot equipped with locomotion, perception, and problem solving. So the first robot basically developed so that it can move, take certain action, percept, and then solve problems. So it was limited, but it was the early development of the robots that time. In 73, the assembly robotics groups at Edinburgh University built Freddy, the famous Scottish robot capable of using vision cameras to locate and assemble models. Right. So it was the early development in AI field. In 79, the first computer control autonomous vehicle, Stanford CART, was built. CART, right? What today we see autonomous vehicles, the foundation was laid out in 1970s, in that decade. In 1985, Harold Cohen created and demonstrated the drawing program, Aron. Right? Today we see many smart devices who can draw for us. We can just show picture to them and they can draw the exact picture, right? By using that AI-based technique and intelligence in it. Then in 85, then in 1990, major advances in AI basically perform scientific demonstrations in machine learning, case-based reasoning, multi-agent planning, scheduling, natural language processing, data mining, web crawling, virtual reality, virtual games, vision. Many such technologies came in 90s. The foundations, again, what we see today, again, I will mention, are the outcomes of those initiatives taken by researchers at that time. Then in 97, Deep Blue Chase, one of the most famous program developed, beat the then world chess champion Gary Kasparov. Can you imagine a computer program itself beat the world chess champion that time, right? In 97. In 2000, interactive robot pets become commercially available. Then MIT display a Kismet, a robot with a face that expresses emotions, right? And then robot Nova explores remote regions of Antarctica and locate meteorites. In 2002, iRobots, Roomba autonomously vacuums the floor while navigating and avoiding obstacles. That is the thing I was mentioning, that you have a home robot and you want him to perform certain tasks, get a glass of water, right, like this, or just go and clean the room like this. So like that, the foundation was laid out in 2002. 2004, NASA's robotic exploration rover Spirit. You might have heard this, right? Spirit and Opportunity autonomously navigate the surface of Mars, and it is still, one of the greatest discovery and innovation in the history. We knew it, right? Then, in 2005, recommendation technology based on tracking wave activity and media usage brings AI to marketing. Do you know who is the leader in using this technology today? Recommendation engine, basically. Recommendation technology. It is AI based technology. But you know who is making the really good profit, excellent profit, and using this technology? First of all, do you know where this technology is used? Yes. At many places, this technology is used. On media streaming platform, don't you see that platform recommends you certain videos, certain entertainment contents?
Yes, sir.
It is used on shopping portals, it is used on media streaming portals, it is used on social media portals, platforms as well. It is used at many places, right? So the Netflix is the company who is making the maximum profit out of it, right? Netflix. They are using the recommendation, using really smartly, and helping you to get the contents which you would like to see, which you would like to watch, right? Which you would like to get involved in, engage in. So that's why they are leading, because of their services, because of their recommendation. Nowhere close to Netflix in that respective technology. But there are many other platforms I have mentioned, like social media, the shopping portals and all. There also this technology can be observed. Then in 2007, Defense Academy research project, DARPA launches the Urban Challenge for Autonomous Cars to obey traffic rules and operate in the urban development. Many developments are happening everywhere to develop autonomous cars, driverless cars, smart cars. And that the competition was held by the DARPA. It is one of the research project academy in US. And the car which would follow and obey all the traffic rules would win that competition. And still they haven't found, the best car, because, the development is still underway. And hope in future we will see such cars everywhere around us. In 2009, Google builds autonomous cars. That was one of the most hyped topic and technology in 2009 that day. Then in 2010, Microsoft launched Kinect for Xbox 360, the first gaming device to track human body movement using just 3 camera and infrared detection. And then in 2011, IBM's Watson computer defeated television game show Jeopardy. It's basically a champions, Rutter and Jinx. In 2011 to 14, Apple Siri came into the market along with Google's Google Now and Microsoft's Cortana. What you see in Windows machines today, 2010, and even Apple's smartphones, these, the foundations laid out that time, decade back in 2011 to 14. So they come up with this assistant, virtual assistants on your smartphones or smart devices to answer questions, make recommendations, and perform certain actions using natural language, right? In 2015, then, an open letter was signed by many scientists, innovators around the world to ban development and use of autonomous space because it is a threat to humanity, we know. And that was signed by around 3,000 plus researchers worldwide in AI and robotics. One of them were Hawkins, right? Stephen Hawkins, Elon Musk, and Wozniak. Then in 2018, announcement of Google Duplex, a service to allow an AI assistant to book appointments over the phone, was developed. In 2020, February, Microsoft introduced the Turing natural language generation, basically like a natural language generation, which was then used, was the largest language model ever published at the 7 billion parameters. There were that many parameters, and technological part of it was added, and that's how that language was developed to deal with some problems. NLG, it was introduced in May 2020 and was in the beta testing in June 2020. Finally, we are today, and the one of the most leader in the technology today are Tesla, Elon Musk. They have come up with an idea of reusable rockets, reusable satellite, and that is really booming the rocketry industries and around the world. And they have redefined, that technology in a really true sense. They have also other business units and product like driverless cars and smart cars in the market, right? So that are the great achievements of AI over the century, over the last many decades, right? And how worth and important this technology is. So you may obviously look, as far as your career prospects are concerned, you may look forward to this field as well. Let's move on to the other part of it, intelligence now, and some of its type. As mentioned before, intelligence means it's an ability of a system, because our aim is to build. First of all, our aim is to build intelligent machines, intelligent devices, intelligent systems. So when we, with that perspective, when we discuss intelligence, when we look at the intelligence, so what it could be? So basically it is an ability of a system to calculate, reason, pursue relationships and analogies, learn from experiences, store and retrieve information from memory, solve problems, comprehend complex ideas, use natural language fluently like humans, classify, generalize, adapt new situations, and deal with any uncertain situations as well. That does mean my intelligence as a whole, and that we want there in our intelligent devices. We want to embed, we want to add that intelligence. You rarely find a human who have all this type of intelligences in it, right? But yes, we want our machine to be smart and even smarter than the humans. So how you define intelligence in that sense then, right? So as you can see, I have listed some of the types of intelligences here. It was described by Howard Gardner, an American development psychologist, and he has defined intelligence which comes in multifold, right? So linguistic intelligence. Linguistic intelligence. Can you give some examples? Linguistic intelligence. How we can define linguistic intelligence at all? And if there is such terms, linguistic intelligence, then what could be its possible examples? Yes? Can you? Linguistic intelligence. So basically, I'll explain. It is the ability to speak, to recognize, and use some mechanisms of phonology like speech sound, intonations, pronunciations, syntax, grammar, semantics, like this. Now, I hope it will help you to understand linguistic intelligence. So can you give some examples now? Yes. So do you know there are narrators and orators who use these skills to speak on certain topics, to speak on certain situations. They make you help understand what had happened behind your scene and sense, and make that reality in somewhere in your mind. Okay, this is how I have realized that situation, that event, that activity, right? So narrators and orators are the example of linguistic intelligence. Then musical intelligence, you know it very well. It is an ability to create, communicate with, and understand meanings made of sounds, understanding of pitch, rhythm. And we have musicians, singers, and composers around us who have the skills in with them. Then logical and mathematical intelligence. It is the ability of use and understand relationships in the absence of actions or objects. So understanding the complex and abstract ideas. So mathematicians have that. Scientists have this, right? The spatial, intelligence. It is the ability to perceive visual and spatial information, change it, recreate visual images without reference to objects, construct 3D images, move and rotate them, and perform all possible operations on those 3D images or those perceptions. So we have the map readers, astronauts, and physicists for that. These type of people or this type of humans have these spatial intelligence skills, or may they have developed it over the time and reach to that intelligence levels, right? Then bodily kinestic intelligence. It is the ability to use complete or part of the body to solve the problem, or fashion products, cover over fine, or maybe some motor skills, manipulate the objects, right? You know how to drive car, so you need skill, how to react to, to steering, the brake, the horn, how you take, when you take the turn left, how you, when you move your vehicle towards the left, right, when you stop, when you look at the traffic signal. There are many things, so that is a kind of different intelligence, how you understand, how you develop the skill and manipulate the objects. Like if you look at the dancers move many moves, many different moves, right? Those moves are not written anywhere, but they move, make such moves based on the musics, based on the modulation of the musics, right? Based on, the events, different maybe situations. So they just come up with a, some artistic work out of it. Players, cricket players, many shots are, standard shots, creating cricketing shots, but many of them are innovated by the, cricketers, cricketing players. We know it, right? So that does mean by bodily kinestic intelligence. Then interpersonal intelligence, the ability to distinguish one or an individual's own feeling, intentions, and motivation as compared to other. Interpersonal skills, intrapersonal skills, right? Like, we have Lord Gautam Buddha, Lord Mahavira, or many such, the great personalities and, around us. So they have developed their interpersonal skills, right? They learn through their experiences and through, the literature and, the information available at that time, and came up with, and, and the intelligence, the knowledge, and they also spread it throughout the world. Then interpersonal intelligence, interpersonal, it is basically the ability to recognize and make distinctions among other people's feeling, beliefs, intentions. Like, on social media, you do it, you participate there, right? You make communication. So how you would be an influencer, a mass communicator, trends. Now, in the social media world, anybody can become a celebrity at any moment, at any point of time. So social media has completely changed the way we live, the way we interact, the way we communicate, right? Earlier, celebrities were known for their work or maybe some creativity, right? But now anybody can become a celebrity over the social media, right? So that platform make really help us to reach to the wider audience and people around the world. Then that is the intelligence. I hope you understand. Did you?
Yes, sir.
See, this topic is really deep, and I just try to cover as much as possible the types of intelligence around us. So this is limitless. I have just listed out 6-7 types of intelligences here, but this could be limitless, right? There are many professions around us. There are many creative ideas, creators around us, innovators around us, disciplines around us. So that basically, that there are different types of intelligences exist, and that is being developed over the time. That nothing is readily available. That is being developed. You are the master, you are the postgraduate student, you're doing master of MCA. So basically, you reach to this platform over the years, right? Over the years, it took you some time and efforts and energy, and to reach to this platform, right? Master of computer application. So it takes time to build that type of intelligence. Let's move on. Now, what is artificial intelligence in true sense then? So you can say a machine or system is artificially intelligent when it is equipped with at least one and at most all the intelligences in it. So what did we see on the earlier slide, or what we discussed, the different types of intelligences that we want to add, encode in artificial device, artificial machine, or any real entity except human. Humans are already intelligent. So we want to add that human intelligence into the machine. That does mean by artificial intelligence. I hope we reach there. There you can understand what does mean by artificial intelligence. So the intelligence is tangible, which we cannot touch, which you cannot see, but you can observe, you can measure. And it is composed of this important components, as you can see on the picture: reasoning, learning, perception, problem solving, and the linguistic skill. Reasoning, again, rational thinking, right? Reasoning is the set of processes that enables us to provide basis for some judgment, some conclusions, some decisions, predictions. Reasoning. The learning, activity of gaining knowledge or skill by participating in activities like study, participating in games, being into the classrooms, experiencing something, and then we learn by examples mentioned before, right? So learning enhances and the awareness of the subjects around us, the objects around us, the things around us. It helps us to understand we are surrounded by what circumstances, what environment, right? Now you are attending this session online, so it helps you to understand how to make use of this platform, how to get participated in this platform. So you need some basic setup, so you learn and get participated, and now you are attending. So learning, this is how it is performed and how it is being done. Then problem solving, it is the process in which one perceives and tries to arrive at a desired solution. Problem solving, you have a knowledge, you know some logic, you have some reason, you learn something, and now you want to solve a problem. So you will be performing certain steps. You may or may not reach to the conclusion or maybe the expected outcome, but there is an approach how to solve a problem. There is a method always. There are steps you have to perform to reach to the desired solution. You may or may not reach to the solution, but you may try it, right? So problem solving, right? It also includes decision making. Yes, fine. May I continue?
Yes, sir.
Okay, fine. So problem solving also include decision making, right? Decision making, why? Because let's say an example, you want to reach to a particular location. You are somewhere at the position now, at the time now. From your location, you want to reach to some other place. You know, there are 2-3 possible routes to reach to the destination, that location. You would opt for the best route, keeping in mind that at what time you are leaving from this place, when you want to reach at that place, and you know, you are aware of the city and those routes, so you know where the traffic will be high, where the traffic will be less, right? Where there will be, you know, the safe road. In terms of safety, you will also consider which route to opt for, right? So it means you are solving the problem. What problem? A very simple one. You want to reach to a particular location in minimum time, right? So that is what you make decision based on understanding, and then you opt for the alternative. So you thought you will go through route 1 and will reach to the destination in less time, but while driving, while routing through that route, you found that there is a heavy traffic. It should not be there today. It's not supposed to be there, but anyway, there was some event, some politicians or something happened, and then there is a heavy traffic, and then you take the alternative decision that time and you move on to the route 2. So you knew the shortcuts. Okay, now, okay, I cannot go forward, so I will take left or take right or move on to the other route. So you take an alternative. So that is a decision making involves in the problem solving as well, right? So these are all basically the components of intelligence. Then perception. Perception means how you acquire the knowledge, how you interpret the knowledge, and then selecting and organizing some information. Like I said, you make decision. On what basis you make decision? Yes, You make any decision. Like very simple example I mentioned, you want to reach to a particular location, you opt for route 1, but you suddenly you found the when traveling over some distance, you found that route is busy, heavy traffic is there. Now you cannot go, and you cannot go back because you want to reach at the other place. So you opt for the alternative. You make that decision. But how we make decision basically? Yes. So we make decision based on our earlier expenses, based on our knowledge, based on our understanding, based on the situation, real life situation, right? So it means we take decisions based on the perception, the way we acquire knowledge, the way we interpret it, the way we select and organize it through sensory information. We see it through eyes. There is a traffic, right? You haven't closed your eyes and still driving. You have used your sensory information and sensory organ, and then decided not to move ahead, take left, move on to the route 2, right? So perception in that sense, right? Perception is required. And the linguistic intelligence, if you want to communicate or you want your machine to speak, to understand the human inputs through some verbal inputs, voice commands. So in that terms, linguistic intelligence is also needed in an artificial machine or artificial device, right? So as we have just seen, it is the ability to use, comprehend, speak, and write in verbal or maybe some written language. So some intra or interpersonal skills if required in the AI-based machines, right? Are you understanding, students?
Yes, sir.
I hope everybody is understanding and enjoying it both. So let me continue on the other part of it. Now,
Yes,
some of the real life applications and research areas in AI. As you can see, the domain of AI is huge in breadth and width and depth. So while proceeding, we consider broadly some common and prospering research area in the domain of AI, what mentioned on the slide you can see. So there is a large area of applications. We have seen on the earlier slides and the earlier discussion also, many applications around us exist, which are based on AI or AI-based technologies. Expert systems. I'll just give you simple examples like, flight tracking system, air route traffic systems, clinical system, medical diagnosis, or some, some mission critical system like some alarm, earthquake, alerts, right? Tsunami alerts. These are all expert systems, right? Natural language processing. We have just seen linguistic intelligence may be needed in artificial device if you want your device to be understood by voice inputs, right? So natural language processing, we have speech recognition, automatic voice input and output, right? Like this. Then neural networks. Neural networks for what? Pattern recognition, such as face recognition, biometric recognition, basically character, the alphabet recognition, handwriting recognitions. Then robotics, for industrial robots for moving, spraying, painting, precision checking, drilling, cleaning, coating, carving. In automobile industries, they use automation, robots, to assemble cars, not just to assemble cars, identifying the spare parts, keeping those spare parts at the right part of the system, then assembling the system in order, and then obviously, right, modifying the parts or maybe performing all the required operations on those spare parts or on a machine as required. So robotics used in industry, not just in manufacturing but other industry as well. I have mentioned Tesla is leading in reusable rockets, satellites, and making driverless and smart cars. So they are using robotics there, robots there. Then fuzzy logic system, like what we see in consumer electronics, automobiles, and at many other places. Fuzzy logic is basically a method of reasoning that resembles human reasoning. Like when I say, most probably human give answers like yes or no, 1 or 0, right? Or they could say like if I ask you, are you honest? So, or maybe, are you sincere? So what you would
Yes.
answer? You would answer
Yes,
as a
sir.
human. So very simply, you will answer, yes, I'm honest, I'm
Ah.
disciplined, right? I'm sincere. Or you may answer, some of you may answer, no, I am not sincere. I'm not honest. So what are the possible options and answers? You must basically give yes and no. Are there any possibilities in between? When I say, what is today's temperature? You would say low, high. Are there any other possibilities in between low and high?
Medium, normal.
Yes, yes. So these are the possibility which fuzzy logic or maybe the fuzzy system help us to get through. So it helps us to measure, system like this. When I say, are you honest? You would say, yes, I'm extremely honest. I'm very honest. Sometimes I'm honest. I'm dishonest. I'm extremely dishonest, like this. Or you would say weather conditions like yes, normal, warm, cloudy, high, low, right? That what we see on our mobile phones also, weather conditions, where weather forecast and all. So there the fuzzy logic system is used, where it helps you to make more possibilities and more ways of representing the data, right? Basically the knowledge representation. So I hope you understand. As I mentioned, this is really a vast field. If I include all the examples and all the technology, it will take me maybe another 2-3 hours or so. But yes, it helps us to understand how wider and richer the AI as a technology is in the market, right? So
Yes,
are you
sir.
understanding? Yes.
Yes, sir.
So let's move on to the other. Now, different task domains of AI. Now, suppose if you are asked to classify the task, what task is the expert task, what task is an ordinary task, what task is the formal task of the AI, there you can categorize the different task domains of AI, like formal task, mundane task, or expert tasks. As you can see in this tree picture, mundane task could be like perception, ordinary basically. Ordinary task could be like perception, like weaving something, computer vision, or it could be speech, voice, right? Or something like understanding through natural language understanding or natural language processing, right? Natural language translation also. Or basically common sense, reasoning, planning, or some movements action to be performed. That could be some ordinary tasks that we would expect from AI, right? These are the task domain which we would like to add and build into the AI. Formal tasks could be like the machine should be able to perform some mathematics, geometry, perform some logic, or should be able to play some games the way we have designed it, like chess. Maybe it depends for what purpose we have built it for. So accordingly, we can make that intelligent device, intelligent machine to perform and to play certain games, right? Then some verifications of objects, things, entities, theorem proving, like this. Expert tasks. When I say expert tasks, what could be the possible expert tasks? Like mentioned there, financial analysis, engineering, scientific analysis, medical diagnosis, fault finding, manufacturing. I just mentioned before on the earlier side as well. Expert system, when I mentioned fuzzy logic, I mentioned like neuroscience, right? Then automobiles, monitoring, medical diagnosis, creativity, innovations, that all is included in the the expert task. So that is how you can understand the different task domains of AI. Let's move on to the next, agents and environments. We started with this in the key terminologies part. Now we are here. We'll try to better understand what does mean by agents in AI and its possible environments. So as mentioned before, AI system is composed of an agent and its environment. So agents can act in their environment. So when I say environment, environments with what? This is an environment. I'm, conducting one session, you are attending it, you are participating it. Whenever I ask a question, right, you you react to it. If you have something to say, if you have an answer, then you speak. It means you are aware of your environment, that you are attending an online session, and then you are maintaining the decorum of it. If asked, only then you will be speaking. If you have a question, only then you are raising a question, you are acknowledging to the speaker as well. It means you are aware of your environments. So when we develop, the artificial machines, the robots, when they will get exposed to certain environments, like home robots gets exposed to the household, the way we have decorated our home, and we place that robot somewhere, and we expect that robot to perform some household activities like cleaning the house, switching on and off the light, fans, right, maintaining, maybe switching, not any different types of, the electronics devices at home, taking care of it, right, and then helping you in some household activities, like whatever you instruct him to, instruct that device to go and do certain activities, like go and get that object, go and get the newspaper, like this. So basically you want that robot to perform this task, right, and that is the environment for that robot. For automobile robots, like those robots are exposed to that automobile manufacturing unit, and you expect that, robot to collect the parts, spare parts from here and there, or wherever you have, kept those parts, and assemble, join those parts and assemble a car, assemble a vehicle. So that is the environment, but that's the designated environment for those type of robots. So it depends what type of agent, basically a computer program you develop, and what type of system you want to build, and what environment it could be for that robot. So accordingly it will perform all the tasks in that environment, right, in that circumstances. So an AI system is composed of an agent and its environment. The agent act in their respective environments, and one environment may or may not contain the other agents. It all depends on us, because we are building the machines. So we have a purpose, we want to solve a particular problem, so we know for what purpose we are developing the robots. So we know what could be the possible environments, right? Now agent is anything that can perceive its environment through sensors. As you can look at the picture, that agent, it looks like a robot, but you may also imagine and think of it as a computer program, or maybe we have added that computer program in a machine, and that machine has sensors, effectors, right, and with the help of those sensors it is perceiving its environment, and if it is required to perform certain actions, so by using its effectors it performs actions in that environment, right? So as you can observe in that picture, so agent is anything that can perceive its environment through sensors, right, and acts through effectors, take action using the effectors in the environment. So what could be the possible types of agents then? Human agents. Like humans have some sensory organs. We have eyes, ears, nose, tongue, right, and skin. So with the help of this, basically, we try to understand. We try to understand the weather conditions, the situations, the events, happening in front of us, and then we react to those situations, and then this is how we live, right? And not just this, eyes, ears, nose, tongue, and skin. There are also other organs like hands, which help us to make movements, make gestures, pick objects, keep objects, right? Legs to walk on, to ride bike, right, bicycle as well, and then mouth to speak. So these are basically the effectors. So in terms of human agent, if you can understand what does mean by human agent, like they have these organs like eyes, ears, nose, tongue, and some sensors and organs like hands, legs, and mouth. So this is how, if you can understand human agent, you can also understand the AI agents. What is basically, they are the programs, and they have given the sensors and effectors to deal with the problem in the environment. Now, what could be the problem? Problem means you want that robot to perform certain task. What task? You want that robot to walk 10 steps ahead and then take left turn, 10 steps ahead from there and take turn back and come at your position. So like this, right? Second is robotic agent, which comes with vision, as mentioned, sensors. It could be one of them, cameras, and some infrared rangefinders also, and some various motors or maybe some control parts as an actuators for effectors. And then we have a software agent, like we do a lot of programmings and intelligent programming to encode some bit string and make that computer to perform certain tasks, to perform certain programs in action, like making calculations, solving a complex statistical problem, predicting something using machine learning algorithms, or maybe some deep learning algorithms like this, right? So, agents are everywhere, but we just need to understand what it is. It is basically something which can learn, which can pursue, basically learn and perform certain actions. So learning, that logic we need to add, how it will learn, how it can learn, right? So we have that for that sensors. Then if it is learn something and if it is required to perform certain operation or perform tasks or solve a problem, then it should use its effectors to perform the action to solve the problem, right? And there could be possible human agent, robotic agent, and software agent. Did you understand that?
Yes, sir.
Right? Then we have agent terminologies mentioned there, like performance measure. How we would measure the performance? Now it depends what type of agent it is, what performance parameter it is, what criteria we have applied. Basically, we are interested in the best possible outcome. So when we look at the best possible outcome, we measure the cost of that outcome, the time it takes, the technology which we have developed and used, and then that outcome is the optimum outcome, the best outcome or not, as compared to the other system and other possible methods available to solve the same problem. So basically, this could be possible parameters to measure the performance. Behavior means action that agent performs after perceptions and any situation is given to be performed. Then percept means perceptual inputs at given instance, how to perceive. Percept sequence means history of all that agent, like since last 1.5 hour you are attending this, so at this slide or at this point we can, so you have a some percept sequence. We have started with some definition, then approaches, and then some key terminology, some application, and now we come on to this topic. So you have some percept sequence, history of past actions. Then agent function, basically a map from the percept sequence to action, like okay, now what, the way I have understood this technology, now what could be the next? Okay, if asked by somebody else to me during my interviews, right, or by my juniors, so what is AI? So I will be able to explain it. Okay, the AI is this. These are the possible the real life applications and research areas in AI. These are the utilities of the AI, like this. So this is all about the agents and its environment. Basically, this topic is too deep to and too important to discuss here, because there are different types of environments, uh, fully observable, partially observable, static, dynamic, discrete, continuous, deterministic, stochastic, single, multi-agent, episodic, sequential, known, unknown, accessible, and accessor, for which we would like to build the artificial machines, intelligent machines, right? So it is not like the way you see or imagine, like only household robot. I have mentioned the automobile robots, maybe the robots which will go into the space and explore the space and come with some interesting and insightful information, right? So it depends on the problem that you want to solve, or that basically you are facing. And there you will develop the robots, or maybe some AI based technology. Then let us move on to the other, Turing test. That's interesting one. As mentioned before, Alan Turing in 1950 introduced a test to check whether a machine can think like human or not. And that test since then is known as the Turing Test. He poses an interesting question. As I told you, many of the scientists at that time fooled, Alan, that how did you think like this? How you imagine that and how you pose question like this? You are fool. So the question was, can machine think? It was an unbelievable question, and that is why the foundations later were laid out on the AI technology, and now today we see, yes, machines can think. Yes, they think like human, they can act like human, unless and until they are developed with this AI techniques, right? So yes, but the concept was laid out that time by Alan Turing. So Turing proposes that a computer can be said to be an intelligent if it can mimic human response under specific conditions, right? So Turing test was introduced by Turing in his 1950 paper. He wrote a research article that time, and in his paper, he's explain all this technology, proposed this technology, computing machinery and intelligence. And there he asked a question, pose a question basically, can machine think, right? So what do you see in the picture? Basically, you can see there are two players. Player A, that is basically a computer itself, and player B is a human itself. They are, somehow hidden from the interrogator, player C. So player C cannot see player and player B. Even player C is not aware where is the player A or where is the computer and where is the human. Player C, that is the interrogator, is just aware that there are two players in the game, player and player B, and one of computer and the other one is human, but don't know exactly who is the computer and who is the human, right? That is the test. That is the imitation way. So that you have to consider. Player A is a computer, player B is a human, player C is an interrogator. So interrogator is aware that one of them is machine, computer, but it needs to identify that on some basis, on some logic, by asking some questions and observing the responses, who is the player and who is the human, who is the machine and who is the human, right? So the conversation between all players is performed through keyboard instructions, right? Or maybe some screen is also given, so the results can be seen, right? So maybe the interrogator will ask some question through speech, or maybe type something through some written instruction. It may ask or give some instruction to both the players. Both the players will react, will respond back to the interrogator. Interrogator will observe the answer, and based on the answer, interrogator has to decide who is the computer and who is the human. But if computer passes the test, it means if interrogator is unable to identify which one is the computer and which one is the human, it means Turing test is pass. And then we can say that computers are intelligent, right? So the test result does not depend on the correct answer basically, but only how closely the responses are like human answer. The way human can react to a certain situation, certain question, can machine do like that, right? So computer is also permitted to do everything, every possible action performed, right? By identification of the interrogator and his or her questions and all. So let us see. Suppose interrogator asks a question to both the player, right? Are you a computer? So what do you expect from the computer? The answer. And from the human?
Yes.
Right. From computer, if computer answer yes, the test fails. Because it itself is a computer, na? So it should say no. Right?
Yeah.
Because it is thinking, and that is the test, na? That is the test that the computer wants to imitate like human. And if it is imitating and behaving and thinking like human, then it would definitely say, no, I'm not a human. I'm not a machine. I'm a human, right? So if the question is, are you a computer? The computer would say, no, I'm not a computer. I'm a human. Isn't it? Isn't
Yeah.
it? That is the
Yes.
test. That is the test. So interrogator may ask some other question like, will you two complex number to solve, which is really impossible for human to solve using pen and paper. without any computing device, calculator, right? So suppose interrogator is posing a question, giving a question and asking a question to both player and player B. What is the multiplication of two 10-digit numbers? So human definitely will not answer that unless the human is using calculator or any other technique, any scientific methods and all. By using pen paper, it's not that easy to answer quickly, right? On the other hand,
Yes.
computer can just give an answer in just a second, right? And just few milliseconds, isn't it? But
Yes, sir.
what computer would do, computer will take a long pause and give the wrong answer, like the human do, right? If computer will do like this, it means computer has passes the Turing test. Are you understanding it? It means machine is thinking, if the same question will be asked to human, what human will do? So human will not solve it because human are not capable to solve complex calculations, right? So I would not solve it. So it will take a long, it would not immediately say, no, I don't know the answer. It will take a pause like human and then say, no, I don't know the answer, or make you the incorrect answer. Now there is a question to the interrogator. Okay, the answer is incorrect. It means if it would be a computer, the result would have been correct. But it is incorrect result, means it is definitely not a computer, isn't it?
Yes, sir.
For the interrogator, it is interrogator is getting the answer from both the players, and player is giving an answer after a long pause, after a long break, taking too much time for calculation and giving itself a wrong answer. Then it is sure for interrogator that it is not a computer, because if it would be in a computer, then the answer would have been correct, right? So it means basically the computer A or player A has fooled the interrogator and making her believe that it is human, it is not a computer. That is the test. That is the test. That is what uh, basically human intelligence have added. That is a simple test basically. That was, as I mentioned, it was the foundation laid by Alan Turing that time, and with that concept, the technology has further grown, and now we are into 2022 today, right? But that was the foundation. And there are many such examples exist that time, like Elisa, as I mentioned, of the chatbot, then Perry, Igwen, Gooseman. You may refer it. It is for you. Chinese room argument also. These are the most popular examples along with this Turing test. So to make Turing test to work proper and pass for computer need these things, these technologies to be added, right? It is not a simple computer, a regular computer, but it has the capability of natural language processing, knowledge representation, automated reasoning, machine learning, vision, and motor control. With this, it can think and act like human, right? Let's move on. So some of the limitations of AI, I'll quickly give an overview of it. So computers can do a great deal, but by their nature, they are limited to algorithms. AI-based technology, machines, systems can perform for what they are programmed for, right? We want it to think like human and behave like human and act like human, but it will take time. They are limited to the logic which we have added into them, right? So limitations, we are mentioning the limitation here, right? The lot of research and innovations are going on that one day you will not differentiate between the human and computers, but we are yet to reach to that level or that advanced level. Now today's computers are faster but more intelligent, but not more intelligent than human. There's a lot of creativity gap also. Researchers, scientists need in the market those who can think out of the box, understand the inequality and limitations of the AI, and overcome those and come with the innovative solutions. Computers don't actually explain things which limit actual understanding. Computers may surprise us, but surprise does not mean creativity. Creativity is needed. Then skill shortage, we know skill shortage and availability of technical staff with AI-based technology, experience, training, and it is necessary. Then cost is one of the most important concern, by the way. of procuring the AI technology. And some other limitations are also mentioned, like implementation time it takes, which may be lengthy, time consuming, right? Then integration challenges, lack of understanding of the state of the art system technologies around us, usability and interoperability with the other system and platforms. So these are basically some of the limitations which will definitely get overcome over the time, but it will take its own time, right? These are the limitations. I hope you understand. Then some of the ethical concerns of AI, why we should be worried, or everyone should be worried about, the AI and AI-based technology. First of all, the potential of automation technology to give rise to job losses. Why job losses? If there is no expertise of AI-based technology, and everybody want to progress and come with the advancements in their respective fields. So you need to have that skills. Unless and until you have that skills, there would be definitely job losses. The need to redeploy or restrain employee to keep them in job. So training cost, time, efforts required. Fair distribution of wealth created by machine. What if there will be machines everywhere? So how that wealth will be distributed, right? Then the effect of machine interaction on human behavior and intention. You know what happens when you spend long enough time on social media, right? You live in the virtual world. So there are always best practices how to use internet, and specifically how to use social media. So the impact of it, of it in human lives. The need to address algorithm biases. You have developed a machine to perform only one task or a certain task. That should not happen. There should not be bias that it performing only some biased task or some desired task. It should act intelligent like human. It should understand the emotions. It should understand the feelings, right? If you are building machines like human, so human do understand the feelings, right? The sentiments. So machine should do also like that, and only then you would say that you have developed machine like humans, right? So that is also required. The security of AI system mentioned before, there was an agreement signed that nobody will develop and sell the autonomous weapons that we see in the sci-fi movies, right? Then the need to mitigate against unintended consequences of these AI-based technologies like smart machines and all. You might have seen in the Transformer movie series, right? There are many other sci-fi movies also. What could be the unintended sequences of some the AI-based technologies and all. So there may be a lot of limitations and concerns and disadvantages, but you can't ignore these risks. So it is worth keeping in mind that advances in AI can, for the most part, create better business, better lives for everyone. And beyond that, if implemented responsibly, AI has immense and beneficial potential, right? So that is there. So we have concluded the first part of this session. It will take me another 10-15 minutes to conclude the remaining part, knowledge representations. So I hope all are there and enjoying the session as well. Students?
Yes, sir.
So it will take me another 10-15 minutes and then we will be there, right? So may I?
Sure, sir.
Students?
Yes, sir.
Yes, sir.
Good. So let me continue till few slides or some remaining topics of knowledge representation. So what is knowledge representation? Humans are based at understanding, reasoning, and interpreting knowledge. That is what we have been discussing since the beginning. Humans, human intelligence. So human knows things, which is knowledge, and as per their knowledge, they perform various actions in the real world. But the question is, how machines do all these things, right? If we want to build AI-based machines or artificial machines, so those machines can definitely do that using knowledge representation and reasoning. So there we need knowledge representation and reasoning in artificial intelligence, right? So this way we can define knowledge representation and reasoning is itself is a part of AI and is mainly concerned with AI agents like computer programs thinking and how thinking contributes to intelligent behavior. Right, so we have a developer program to perform certain tasks. Okay, it will perform the designated task, but is it learning something? What if some new action will arise, some new situation will arise? Will it take the action appropriately even we have not programmed it for that? So that is what we wanted in the AI based machines, right? We want that machine to learn and deal with the some unprecedented situation, unknown situations, right? So that is the knowledge representation reasoning in AI. So this KR or KRR sometimes is responsible for representing information about the real world so that a computer can understand and utilize the knowledge, human knowledge basically, to solve the complex real world problems. Now, what complex real world problem? Many things are around us. You want to automate everything, right? You need to have medical diagnosis, automated medical diagnosis, right? So you want to communicate the machine. You want to build a machine which can communicate with the humans. What do you need? How may I help you like this? The way we are getting assisted using smartphones, right? We have the human knowledge and we do not add it into the system, we will be not able to make machine think and behave and act like humans. So in AI, how machine understand, reason and interpret knowledge and perform various actions come under this knowledge representation and reasoning. Then, so following are some of the kind of knowledge which needs to be represented. What to represent then? Okay, we have a knowledge. Knowledge of what? And if we have a knowledge, then how to represent that knowledge? So there must be some way of representing the knowledge, or there must be some way of creating some knowledge base into the machine so that it will, have that memory, that inbuilt knowledge, and will perform human-like actions, think like human, right? So what to represent first? So objects, we are surrounded by many real and non-real objects around us, right? So all the facts about objects in our word domain. For example, guitars contain strings, trumpets are bass instruments, table is made of wood, right? That is a knowledge. That is a knowledge, right? So that knowledge, how we can add about objects and all, add into the machines, and how we represent into the machine basically. Then events like some actions which occur in the real world, day, night, right? Maybe then we have first day of the month, last day of the week, a particular day of the week, then right particular time of the day, right? Like this events, or maybe some movements, some actions like this. So whatever the events, that is also a knowledge about all those events. Then performance. Again, performance. How we measure performance, it depends on the outcome. How much the cost of technology, the time, the efforts involved in it. So basically it describes behavior which involves knowledge about how to do things, how to do things in a smartest way, in a best possible way. And then meta knowledge, that is knowledge about what we already know. Do you have, suppose I ask you a question, you are the postgraduate student, maybe in first year, second year, or third year. So do you have a knowledge? How much you know about yourself? How much you know about your own skills? That is a meta knowledge, right? Then facts basically are the truths about the real world and what we want to represent. Fact, the reality. This is true, this is false, this is correct, this is incorrect. And finally, the knowledge base. The central component of this KRR, or the knowledge representation system, is a knowledge base agents. And knowledge base is basically a group of some logic, some information, right? And in the later part we will see how there are ways how that knowledge is represented different techniques. Let's move on. Types of knowledge. If asks to you, now you understood knowledge means what? So knowledge is awareness and familiarity of gain experience. The familiarity gained by experience of facts, data, situation, events, objects, whatever around us, around you. But what could be the possible types? This could be the possible types, like the knowledge could be declarative, procedural, or maybe meta, heuristic, and structural. Declarative means it is to know about something. It includes some concept, facts, object, or it could be, describe, express in some declarative sentence, like I mentioned, today's weather is too cool, too warm, too hot. So you are, you're describing the temperature of the day, but the way you are describing that matters, right? So the way you have added and explained the situation. Then procedural knowledge is known as some imperative knowledge, like knowledge is responsible for knowing how to do things, how to perform certain tasks, or what process or method can be applied to perform certain tasks. So it includes some rules, strategies, procedure mentioned, procedural knowledge, some agendas, some steps, that how to perform a task, how to do something, procedural knowledge. The way, for example, you join this online session. So how did you join it? So you started a computer, start the internet, then you log in on Zoom, and then you just join using the credentials given to you for the meeting. So there are steps involved, procedure involved. So procedural knowledge. Then meta knowledge mentioned before, knowledge about the other types of knowledge, what we already know, what we know about the environment, what we know about the capabilities and incapabilities of the machine, and many other aspects. Then heuristic knowledge. Heuristic basically is representing knowledge of some expert in the field of subject. So it is basically based on some previous experiences, previous awareness, or maybe some approaches which the system already knows, and then we'll pick one of the best method to perform a certain task. Heuristic knowledge. So it is an approach to problem solving in which the machine, the intelligent machine, produce the best possible solution with reasonable time frame. It means machine have the knowledge that the given problem can be solved by using number of methods: method 1, method 2, method 3, method 4, method 5. But machine has picked the method 3 because it knows method 3 will give you the best possible outcome. It will take less time, less memory, and will give you the outcome in a better possible way, right? Or maybe as compared to other methods. So that does mean heuristic knowledge, right? Finally, we got structural knowledge, is basic knowledge for problem solving. It describes relationships between the objects, events, situations, even the knowledge itself, the knowledge component itself, and accordingly it will help machine to pick the appropriate action accordingly. So it describes the relationship that exists between concepts and objects. Then we got some requirements for knowledge representation system. If there could be this possible ways of keeping knowledge in the knowledge database, these are the different types of knowledge base, and it helps to store knowledge into the intelligent machines in these many possible ways. Then what could be the possible basic requirement basically for knowledge as a system, knowledge representation system? What is the requirement for that system? So we want the knowledge representation system to be good enough with this certain properties. We want the knowledge representation system and all the knowledge base in it should have accuracy, representational accuracy. So it is basically the ability to represent all required knowledge. If we have designed a system to perform certain tasks in the given environment, so it should perform all those actions which we have built it for, right? So accuracy. Then inferential adequacy. It is an ability to manipulate the representational structure to produce new knowledge corresponding to the existing structure. So it should be able to infer something based on the existing knowledge, right? It should infer, it should apply certain logic and perform some action to some unknown situations, or maybe to some new situations, right? Then inferential efficacy, it means the ability to direct the inferential knowledge mechanism into most productive direction. And then finally, acquisitional efficiency is the ability to acquire the new knowledge easily using automatic method. So knowledge acquisition, basically, into the knowledge base using automatic methods. So learn by example, learn by experience, learn by performing actions. So that automatic learning knowledge acquisition is expected from the artificial devices or machines. Finally, there are 4 types. I'll just quickly give an overview of this. We got logical representation, semantic network representation, frame representation, and product rules. So I will just quickly give an overview of it, right? So logical representation basically is a language with some concrete rules which deals with propositions and has no ambiguity in representation. For example, you might know the propositional logic and predicate logic are basically 2 ways how logical representation of knowledge can be, how knowledge can be represented using some syntax and semantics using these 2 techniques, propositional logic and predicate logic, right? So syntaxes are basically, rules. We decide how we can construct legal sentences, and then how to write those symbols and all. And semantics, basically, what is the meaning? What is the rule? Why, when we use a particular syntax, what will happen when we use a combination of multiple syntaxes, and what would be the inference and logical conclusions of it, right? So semantics, the grammar behind it, right? So that is there in the logical representation. Then we got semantic network representation. So semantic networks are basically alternative to the earlier one, logical representation, predicate and predicate and propositional logic. So semantic networks, the possible types could be easy relation, that is inheritance, and kind of relation. As you can see in the picture, there is an example. Suppose you have some information like the information you have, and you want to represent that information using some representation technique. And one of the technique which is available is semantic network representation, and it could be represented using some nodes and arcs, right? It would be basically a graphical network. So suppose you want to represent a cat, its name, and it is a mammal, it is owned by someone, then its color, some information there. Now, how you would represent that information using this semantic network representation that is depicted in the picture here, right? So you can say that, yes, Tom is a cat. Tom is colored white. It is owned by Priya. Cat is a mammal, and all mammals are animal, right? So like this, this type of representation technique can be used in knowledge representation itself, knowledge representation system. Then we got production rules. Production rules consist of some condition action pairs, which mean if condition, then action. So it has 3 important parts: the set of rules, working memory, and recognized cycle. So in production rule, agent checks for the condition, and if condition exists, happen basically, then a particular action will be taken, right? So the condition part of the rule determines which rule in the production rule may be applied to a problem. Like, you have an umbrella at home, it is a summer. Will you take umbrella and go out and walk, or maybe do your job? No, it is a summer. You may use an umbrella, maybe just to prevent yourself from that hot weather, right? Will you do the same thing in the winter? Will you take your umbrella and go out? No, because no hot weather, no raining, so why would take the umbrella, right? So you would do a particular knowledge and some rule when to perform certain action. So condition, Condition is raining, take umbrella. Condition is hot weather. In that case also you can take umbrella, but it's a winter. So you don't need umbrella in that case. You may need a sweater or some warm clothes in that case. So condition action, right? So condition part determines which rule may be applied to a problem, and the action part carried out the associated problem solving step. So this is basically known as recognize, act, cycle. Recognize, understand the situation, and then act. Condition, action, right? Recognize, act, cycle. And one component is not shown there. Production rule mentioned in the list. Working memory. Working memory means contains basically some description about the current state of the problem. What is the current state of the problem and how to solve it? Which rule needed to be applied so that problem will get solved. So you have observed the current state. Raining. You want to go out. So take umbrella. Right. So you should have some working memory also in knowledge representation system as far as production rule are concerned. One example is mentioned there. If at bus stop and the bus arrives, then take action, get into the bus. And now if you get into the bus, then pay for the ticket, the journey. And if you see a seat is available, go and sit there. So there is always an action based on certain condition is performed, right? So this is all about production rules. Then finally, we reach to the final slide and final topic of this session, frame representation. So what is frame representation? Frame is basically like a record-like structure, right? So tables. What do you see in the tables? Yes. What do you see in the tables?
Rows and columns.
So how information is represented? Rows and columns, right? So column basically variables and rows are basically observation, the values, isn't it? Right? In terms of table, the column represents the variables, right? And row represents the observation, the exact values of those variables. So this is like a frame representation, and just the nomenclatures are different. Like frame representation mentioned, slot filter is mentioned. So that's why I have mentioned one example at the book, a frame for book. Like how information you can store. If you want to store information about books, so you may store. There are fields like title, author, publication, date of publication, publisher, right? And then in filters, you can store information like if it is a title, then introduction to A and Kia. If it is a publisher, it could be elsewhere, or it could be author, then Ross, right? Russell and Norvig, like this. So that is how information can be represented in the tables, or here it is mentioned as frames, right? Frames for your understanding. Student, that's all about from my end, right? I hope you have understood this topic. It will further help you to take this topic in your prospective career, and you look forward to this field as one of the career opportunity, right? So I have taken a lot of information from these places, particularly from the book by Stuart J. Russell and Peter Norvig, Artificial Intelligence.